after. So we're gonna start talking about the derivative now. So the definition of derivative is that the limit has the following interpretations. So it's called the slope of the tangent. This cooperates with me. So the slope of the tangent to the curve y equals f of x at the point PA and f of a. We've seen this with limits. So the limit as h approaches 0 is f of a plus h minus f of a all over h. So it also is interpreted as the velocity of the distance function s of t, where t is equal to a, the rate of change, and the derivative, all to respect of x when x is equal to a. So the derivative function is denoted as f prime of x, is defined by just finding the limit, provided that the limit exists. So when we use the above limit to determine the derivative of a function, it is said that we are using the first principles. So in advanced functions, you guys use the quotient, the difference quotient to find the instantaneous rate of change. You are literally finding the derivative at that point without even knowing. So let's do an example first. So for example 1, we want to find the derivative of the function f of x is equal to x squared at an arbitrary value of x. So at whatever value of x, we're going to try to find the derivative of the function f of x squared. Okay? So the derivative for any value of x, that's what we're trying to find it at. So we're going to determine the process of finding the derivative and finding the derivative from the first principles. So based off the first principle, we're literally just using the quotient rule. So it's f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. So even without knowing it, last year when you guys did the difference quotient, you guys were actually finding the derivative of a function. So we get limit as h approaches 0 of f of x plus h, which is just x plus h squared. Remember, wherever we see x, we're going to sub in x plus h minus x squared all over h. So our numerator looks like a difference of squares. So we got the limits of h approaching 0 of x plus h minus x times x plus h plus x. And that would be all over h. So what we end up getting when we simplify this is just simply 2xh plus h squared all over h. So I can factor out my h, which gives me h times 2x plus h all over h. My h's cancel out. So I'm left with 2x plus h. And because h is approaching 0, I can just sub in 0 for h. And I'm left with 2x, which is my derivative of the function. What you guys are going to learn is that when we find the derivative using specific laws and rules, all you're going to realize is a derivative without using the difference quotient is you just take the exponent, bring it as your coefficients, and take your exponent and subtract it by 1. So we get 2x to the 1, or just 2x. And that would be our derivative. Okay? So we're finding the derivative here just using the limit of doing f of x plus h minus f of x all over h. Let me just rewrite this. caught myself in a mistake again, but that's fine. So with this line over here, the x's cancel out, so we get h times 2x plus h. Or if you wanted to expand it, you get 2xh plus h squared, or you can just leave it like that. So example 2, we want to find the slope of the tangent to the line of f of x is equal to x squared at the point 1 and 1. So what we're finding is the slope of the tangent at x is equal to 1 is equal to f prime at 1. So because we already know that when we find the limit, this just equals to 2x, all I need to do is sub in my 1 for x, so we get 2 times 1, which is equal to 2. So the slope of the tangent to the line of f of x is equal to x squared at the point 1 and 1 is equal to 2. And now the next one, we have an object travels according to the equation s of t squared, where t is in seconds and s is in meters. What is the velocity when t is equal to 6? So again, we have to find the derivative. So we have s of t is equal to t squared. And it's the exact same thing as saying x squared, y squared, z squared. It's the exact same thing. Our derivative is always going to be 2t, okay? And now to find our velocity, we take our derivative, so this becomes velocity of time over time is equal to 2 times t, which is equal to 2 times 6, which gives us a velocity of 12 meters per second. So in derivative notation, if y is equal to f of x, we can represent the derivative by writing y prime, which reads as y prime, or dy over dx, which is Leibniz notation, read as dy over dx. It's not a fraction, it's just the derivative. Or f prime of x, which is f apostrophe x. Those are different ways to symbolize the derivative. The differentiation operator, so for example, d over dx of x squared is equal to 2x, which means says perform the differentiation. So it's just the derivative. So derivative is a noun and differentiate is the verb. A little English lesson there. So for example, the proper form, so if y is equal to x squared, then y prime is equal to 2x, or dy over dx is equal to 2x, or dy dx at that specific x value equal to 3 is equal to 2 times 3, or y prime such that x is equal to 3 is equal to 2 times 3, which gives us 6. So these are all the proper ways to write the derivative in a proper way. However, if f of x is equal to x squared, then f prime of x is equal to 2x, and then f prime of 3 is equal to 2 times 3. Okay? However, don't write it like this, so this would be improper. Would be y at x is equal to 2x. That would be an improper form. Or y prime at 3 is equal to 2 times 3. That is also improper because we're taking the derivative of the function f of x, not just of y. So the definition of the normal, so the normal to the graph of the function y is equal to f of x at a point P is the line that is perpendicular to the tangent at points P. So we're going to get into an example that involves the definition of normal. So we have given f of x is equal to square root of x plus 2, where x is greater than or equal to negative 2. We want to find the derivative of f of x using the first principle. Okay, what do we, by saying finding the derivative using the first principle, what are we going to be using? We're going to be using limits. So first principle implies limits. So in order to find our derivative, we're going to do f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h, which is equal to the limit as h approaches 0 of x plus h plus 2, so the square root of that, minus the square root of x plus 2 all over h. So, what do I have to do to rationalize my numerator? What do I need to do to rationalize my numerator? We're going to multiply by the conjugate. Can anyone tell me what the conjugate is? Multiply by the conjugate, which is what? Does it be square root of x? Yep, plus 2h plus square root of x. Perfect. So we're going to multiply by root of x plus 4, or x plus h, sorry, my h's look like 4, plus x plus 2, all over square root of x plus h plus 2, plus the square root of x plus 2. So now when we simplify, we get the limit as h approaches 0 of x plus h plus 2 minus x plus 2 all over h times root of x plus h plus 2 plus root of x plus 2. And now what you're going to notice is that we can cancel some things out. So my positive 2 cancels out with this 2 because when we take out the bracket, it becomes negative 2. My x crosses out with negative x. And we're just left with h on numerator, which means that we can cancel out this h with my denominator given h. So we're left with the limit as h approaches 0 of 1 over x plus h plus 2 plus x plus 2 to the square root. Now, because h is approaching 0, I can sub in h into my denominator, so sub in 0. So we're left with 1 over the square root of 2, or x plus 2, plus the square root of x plus 2, which is equal to 1 over 2 times the square root of x plus 2, which means my derivative is f prime of x is equal to 1 over 2x plus 2. I'm taking the square root. So this is what my derivative would look like. Okay, I know it looks complicated, but we're just using the limits of f of x plus h minus f of x all over h, and we're just rationalizing my numerator so that I can simplify it and so that I can find my derivative. And remember, guys, since h is approaching 0, I can sub in 0 for h to get rid of the h. Any questions so far? Okay, no, so far so good, hopefully. We shall see with the next question. So question B, we are going to determine the slope of the tangent line to the curve of f of x at the point x is equal to 2, okay? So I'm going to find the slope of my tangent where x is equal to 2 using my derivative, okay? Which is equal to finding f prime at 2. So we have our derivative was 1 over 2 times the square root of x plus 2. Can someone tell me what the slope of my tangent is to the line, to the curve at x is equal to 2? Thank you, Mohammed. It is going to be 1 over 4. So you get 1 over 2 times the square root of 2 plus 2, which is equal to 1 over 4. So this is going to be the slope of my tangent to the curve at the point x is equal to 2. Now, we need to use that to determine the equation of the normal to the curve, f of x, at the point x is equal to 2. So we have to find the equation of that line. So we know the slope of the tangent. That we know from the previous question. So we know that the slope of the tangent, so m of the tangent at x is equal to 2. We know that is equal to 1 over 4. Okay? And remember, the definition of the normal is that the line is perpendicular to the tangent at point P. Okay? So, when I talk about perpendicular, what do I need to find? What do I need to do with 1 over 4? You guys learned this in grade 9 or 10 where you're finding the right bisector of in a circle. So we're going to take the negative reciprocal. So negative reciprocal to find the normal. So m of the normal, or m perpendicular, is going to be negative 4. So now, because our function is f of x is equal to square root of x plus 2, I need to figure out what my y value is when x is equal to 2, because I need a point a and f of a. So I'm going to evaluate for x at 2, which is the square root of 2 plus 2, which is equal to square root of 4, which gives me 2. So my coordinates at x is equal to 2 is going to be 2 and 2. So now I can find the equation of my line to the normal. So I'm going to use y minus y1 is equal to m times x minus x1. My slope is negative 4 because of the normal of the negative reciprocal. My y1 is going to be my 2, and my x1 is also going to be 2. So I get y minus 2 is equal to negative 4 times x minus 2. So I get y minus 2 is equal to negative 4x plus 8. So in standard form, it would be 4x plus y minus 10 is equal to 0. Or in y is equal to mx plus b, we get y is equal to negative 4x plus 10. Usually when we want to find the equation of the normal, we can either leave it in standard form or y equals mx plus b. On a test or an assessment, I will specify which one I would like it in. So this one's in standard form. And this one is in y is equal to mx plus b. Okay, so this would be in standard form, and then we have it in y is equal to mx plus b. Any questions about this example? Any questions, any confusion? I'll give you guys a minute or two to copy this down. All right, so 1 more minute and then I'll move on. Okay, so the next one is going to be a bit of a longer one, so I'm going to take my time with this one. So we want to find the equations of the lines in standard form to the tangent to the graph of y is equal to 1 over x plus 2 and is parallel to x plus 4y minus 2 is equal to 0. So I need to change my standard form equation into y equals mx plus b to find my slope. So I'm going to get 4y. So we have x plus 4y minus 2 is equal to 0. So we're going to isolate for y to get to y equals mx plus b is equal to negative x plus 2. So we get y is equal to negative 1 over 4x plus 1 over 2, which means that my slope is going to be negative 1 over 4. Okay, and in order for you guys to remember what 1 over x plus 2 looks like, we have a vertical asymptote at x is equal to negative 2. And our graph looks like this. So at negative 3, our y value is going to be negative 1. and that x is equal to -1, our y value is going to be +1. So now we have to figure out how to come up with the equations of the lines in standard form. So what do you guys think we have to do next? So we're given our slopes, okay? We need to figure out a way to come up with the equation of our lines in standard form to the tangent of that graph. So remember, this is all about first principles. So we're going to be using our limit. So since our slope is -1/4, I can set -1/4 equal to my limit as h approaches 0 of 1/x plus h plus 2 minus 1/x plus 2, and that's all divided by h. Okay, I don't want to put it in a complex fraction because that's going to confuse some of you. So all we have to do is literally cross multiply now. So I get -1/4 is equal to the limit as h approaches 0 of x plus 2 minus x plus h plus 2 all over x plus h plus 2 times x plus 2 times 1/h. So what you're going to notice is my x's cancel out. My 2's cancel out, and I'm left with -h. And my h also cancels out because of this times 1/h, which means that my limit as h approaches 0 is going to be -1 over x plus h plus 2 times x plus 2. And because h is approaching 0, I can just sub in 0 for h. So in reality, we are left with -1/4 is equal to -1 over x plus 2 times x plus 2, which is the same as saying -1/4 is equal to -1 times x plus 2 all squared. So now because we have our slope, we can find the x values of the points so that we can create our equations in standard form. So if I were to simplify -1/4 is equal to -1 times x plus 2 all squared, we would end up getting x plus 2 squared is equal to 4. Okay? The negatives cancel out because when we cross multiply, we get rid of them. So it's just 1/4 is equal to 1 over x plus 2 all squared. So now in order for us to isolate, we would have to square root both sides. So we're left with x plus 2 is equal to plus minus the square root of 4, which gives us 2. So we have two x values that we can look at. One of them is going to be x is equal to 2 minus 2, which gives us x is equal to 0. So that's 1. Or the other one can be x is equal to -2 minus 2, which gives us x is equal to -4. Okay, so we have two different x values that we can look at. So how many equations of the lines in standard form to the tangent are we going to have then? So because there are two x values, that means we're going to have two equations that we need to find in standard form. So let's take a look at our first equation that has to do with x is equal to 0. So we can find our equation where y such that x is equal to 0. So that is equal to, so we just sub it into our original equation. We have 1 over x plus 2, sub in 0 for x, so we get 1 over 2. So my first point is going to be at 0 and 1/2. Okay? Now, because we have a second solution to our limit, we would find the equation of y where x is equal to -4. So that gives us 1 over x plus 2, which gives us 1 over -4 plus 2, which gives me -1 over 2, which means that my second point we're going to look at is -4 and -1 over 2. So this implies that we have 2 points of tangency. So if I go back to my graph over here, I'm going to have my first point of tangency at 0 and 1/2, which is right over here. And my second point of tangency is going to be at -4 and 1/2, which is going to be somewhere over here. Which means that I'm going to be finding two equations of the tangent. So I'm going to find one that hits right here. And I'm also going to find one that hits right over here. As you can see, they are parallel to each other, which is exactly what we want. So now what we can do to solve for each equation is we can put it into our standard form. So equation 1, y minus y1 is equal to m times x minus x1. So we know our slope is -1 over 4. We know our first point is going to be 0 and 1/2. So this is going to be x1 and y1. So now I'm just going to sub it in. So I get y minus 1 over 2 is equal to -1 over 4 times x minus 1 over 2. Sorry, x minus 0. X minus 0, which means that when I simplify that, I get x plus 4y minus 2 is equal to 0. Okay, I'm just going to expand it for you guys just to make it easier for you. So I get y minus 1/2 is equal to -1 over 4x. Okay, and obviously we cannot multiply it by 0. So what I'm going to do is I'm going to multiply both sides by 4. So I get 4y minus 2 is equal to negative x. I bring the x over, and I get 4y minus 2 plus x is equal to 0. So that's how I expanded it and simplified it. And then for my second equation, I'm going to do the same thing, except my point is going to be negative 4 and negative 1/2. So I get y plus 1/2 is equal to negative 1 over 4 of x plus 4, because a negative times a negative gives us a positive. So we get y plus 1/2 is equal to negative 1 over 4x minus 1. So what I can do is multiply both sides by 4. And I get 4y plus 2 is equal to negative x minus 4. And then I would have to bring everything over to the left side. So I bring the x and the negative 4 over, which gives me x plus 4y plus 2 plus 4 is equal to 0. And we get x plus 4y plus 6 is equal to 0. So I have two equations of the lines in standard form, which is tangent to the graph of f of x, where y is equal to 1 over x plus 2.